Hi, this is your Professor Sudha Kolathuparambil, derivatives of logarithmic function. First, look at the derivative of natural logarithmic function. Natural logarithm is logarithm with base e. So, log with base e of x. That is a natural log function. So, assume we have y equal ln of x, or we can write y equal log with base e of x. We can convert that into an equivalent expression, exponential form, e power y equal x. Since it is a function of x, instead of writing e power y, I can write e power f of x equal x. Now differentiate both sides with respect to x. So I can write d over dx e power f of x equal derivative of x. Here I am going to use the chain rule. So e power f of x times the derivative of the inner function. So derivative of f, that is f prime of x. Derivative of x is 1. E power f of x, we know that is just x, that is here. Okay. Then f prime of x equal 1. So f prime of x is 1 over x if we divide both sides by x. So f of x is actually y. Y is ln of x. So you can say that derivative of ln of x is 1 over x. Domain of ln of x is x greater than 0. So we can say that for any positive number x, derivative of ln of x equal 1 over x. If y equal ln of absolute value of x, here since it has absolute value sign, x can be positive or negative. So this is equivalent to ln of x or ln of negative x, because x can be positive or negative. It is positive x if x is greater than 0. This is negative x if x is less than 0. Let's see what will be the derivative of that. Derivative of ln of x when x is greater than 0, we already know that is 1 over x. And for the derivative of ln of negative x, we can use the chain rule. So it will be 1 over negative x times negative 1. So that will be 1 over x. Here I am using the rule derivative of ln of u, where u is a function of x. It will be 1 over u times u prime. That is the chain rule. So if x is negative, also we are getting the derivative is equal 1 over x. If x is greater than, also it is 1 over x. From this we can conclude that derivative of ln of absolute value of x equal 1 over x for all x not equal 0. Let's find the derivative of log function with any other base other than e. So first we will apply the change of base formula. So we can rewrite this as ln of x over ln of a. Ln of a is a constant. So while taking the derivative, I am going to view this problem as 1 over ln of a times ln of x. That means constant times a function. So derivative will be constant times derivative of the function. So constant is 1 over ln of a times the derivative of the function, derivative of ln of x. That will be 1 over ln of a times derivative of ln of a means that is 1 over x. So the derivative of log base a of x equal 1 over ln of a times 1 over x, or you can write the x in front of that and write under one common fraction bar. Instead of just x, if you have u as a function of x, then you can write this as 1 over ln of a times 1 over u times u prime. Like apply the chain rule. Let's look at some example. We need to find the derivative of this function. So this is a constant times function. So derivative will be constant times derivative of the function. So it will be constant is 3 times derivative of the function. Derivative of ln of x is 1 over x. So the answer is 3 over x. Since it is derivative, I am writing y prime. Second question, y is x cube ln of x plus 5x. So for the first one, we need to apply the product rule. This is f and g. So f prime g plus fg prime. So y prime will be 3x square times g plus x cube times 1 over x. X will cancel and you will get x square. X square is the GCF. Factor that out. Other factor will be 3 ln of x plus 1. We are getting 1 here because x square divided by the GCF x square will be x square divided by x square is 1. Oh, I forgot to add the derivative of the other term. So we need to add the derivative of 5x. Derivative of 5x is just 5. Third question, we need to find the derivative. Here we will be using the quotient rule. Quotient rule is f prime g minus fg prime divided by g square. So f is ln of absolute value of 4x and g is x square. So this is f and g. So f prime will be 1 over 4x. Then you need to apply the chain rule. So multiply by 4. So 4 will cancel. You will get just 1 over x. So f prime is 1 over x. G prime is 2x. So f prime g minus fg prime. Then multiply by g square. So f prime g minus f g prime is 2x whole divided by g square. G is x square, so x square square. Here one x will cancel and only one x will be left, and we have 2x ln of absolute value of 4x divided by x power 4. X is common factor, so I'm factoring out x. So x divided by x is 1 minus 2 ln of absolute value of 4x whole divided by x power 4. One of the x will cancel and we will get x cube at the denominator. So the final answer is 1 minus 2 ln of absolute value of 4x divided by x cube. Let's look at some example. We need to find the derivative of this function. So we are going to apply the rule you just learned. So it will be 1 over ln of 8 times 1 over x. So instead of a we have 8. So it will be 1 over ln of 8 1 over x. If it is just log x, there is no base written here, right? That means that is the common log. That means the base is 10. So it will be 1 over ln of 10 times 1 over x. Third question, a is 4. Instead of x, we have a function of x. So we will apply the chain rule like 1 over u times u prime. So it will be 1 over ln of 4 times 1 over x square plus 1 times derivative of this function. So that will be 2x. Do not cancel this 4 and 2 because that is ln of 4. This whole thing is a constant. So we can write under one fraction bar 2x over ln of 4. Oh, let me write x square plus 1 in the beginning, or use proper parenthesis. So x square plus 1 times ln of 4.